Hey everyone! In this video, we're exploring the diagonal magic pattern, a classic matrix problem where you're given a number n, and the goal is to fill an nxn grid diagonally in a specific order. Let's break it down. Let's first understand the pattern. You'll notice that the numbers are filled diagonally, almost like lines passing from the top right to the bottom left, or quadrant 1 to quadrant 3. The first diagonal starts at the top left and prints 1. The second diagonal begins just right of that and moves downwards, printing 2 and 3. This continues with each diagonal adding more elements as it moves across the matrix. In total, there are 2n1 such diagonals. For each diagonal, we use a simple trick. We figure out which coordinates fall on that diagonal using a basic equation, and that helps us place every number exactly where it belongs. To build the solution, first, we initialize an n by n matrix with zeros. Then, we loop through each diagonal from 0 to 2n minus 2. For every diagonal, we compute coordinates based on the pattern. If the position is valid, we place the next number. And we keep going until the matrix is completely filled. Here's how the code works. We start by creating an n by n grid filled with zeros. Then, we loop through each diagonal, using a simple formula to find where the number should go. If the coordinates are valid, we place the next number and move on. Finally, we print the matrix diagonal-wise. Now watch closely. Here's how the pattern comes together. In the first iteration, we hit diagonal 0, filling position 0, 0 with 1. Next, diagonal 1 fills values diagonally from top to bottom. And as we move forward, each diagonal continues this flow, filling positions based on our simple formula. You can clearly see the entire matrix getting filled, one diagonal at a time. And there it is, our final pattern. So by just looping over the diagonals and calculating the positions, we've used the structure of the matrix itself to solve the problem elegantly. A perfect example of how smart math and code work hand in hand. If you found this helpful, don't forget to like, share, and subscribe. Hey, check out the blog for the full breakdown.